What happens to quantum entanglement during decoherence? Imagine two particles that are connected in a way that, if you measure one, you instantly know something about the other, no matter how far apart they are. This strange link is called quantum entanglement. It's a core part of how quantum mechanics works and is the basis for many emerging technologies. But what happens to this connection when the particles aren't alone anymore? When they interact with their environment? That's where decoherence comes in. Quantum entanglement relies on a property called quantum coherence. This means the particles maintain specific phase relationships that keep their entangled state intact. When they're isolated, these phase relationships stay stable and the entanglement persists. But in the real world, particles are never perfectly isolated. They constantly interact with surrounding particles, light, or vibrations. These interactions cause decoherence, which is like noise that disturbs the delicate quantum state. During decoherence, the environment causes the phase relationships between the particles to weaken and eventually disappear. This process affects the system's density matrix, which is a way scientists describe the state of a quantum system. The off-diagonal elements of this matrix, which representing the coherence between different quantum states, decay over time. As these elements fade, the system loses its quantum superpositions and entanglement. As a result, the particles become disentangled. Their quantum information leaks into the environment, making it impossible to observe or use the original entanglement. The particles start behaving more like classical objects, with no special quantum connection. This transition from a pure quantum state to a mixed classical state is a big challenge for quantum technology. In quantum computers and communication systems, maintaining entanglement is essential. But decoherence acts like a ticking clock, limiting how long entangled states can last. To fight this, scientists develop ways to isolate quantum systems better or use error correction techniques. These methods help preserve entanglement longer, making quantum devices more reliable. So, in simple terms, decoherence causes the quantum link between particles to fade away. It turns a special, connected quantum state into a more ordinary, disconnected one. Understanding this process helps us find ways to keep entanglement alive longer and build better quantum technologies.